Now we are in the last bunch of presentations before the social event, and it's a nice opportunity to thank Sipfront again for the social event. So we all have to thank them for sponsoring what I'm sure will be a very nice time together. And Dominik today will be talking about automating WebRTC test codes, and I guess there will be some demos involved, some really cool things happening. So I'm really looking forward to that. Thank you.
Thank you. First of all, I want to thank you all for having me here. It's really an honor, and to be in this great city, I'm really thrilled. It's really a different thing. So what I want to present today to you is what we at Sipfront created in order to test WebRTC calls, SIP calls, and even PSTN calls, and all combined, so that you can call from WebRTC to PSTN or to SIP or in any form. But first, about me. So I'm Dominik Ridjic. I'm from Vienna, and I'm almost 70 years in the telecom industry. Mostly, I've been working the developer side, so I've been creating mobile apps for Android, for iOS. So I know this side pretty well. But recently, I've switched sides and did some more testing with Sipfront. And yeah, that's what I want to show you. So this line, I guess most of you at some point, at least those of you who are developers, have thought to themselves, okay, I will build my own test framework, because every time you push some new change, you have to do, maybe you have an Excel sheet and you type out the numbers and do some calls, and it's really repetitive, and it's also error prone because humans make errors, and you do not two persons will not always perceive the audio quality of a call in the same way. For some person, maybe the audio is okay. For another person, it is not okay. And what we are trying to do is to do something more objective, where we measure this stuff and where you can track over time how it behaves with changes that you do to your app, to your platform, to the generally, yeah. So, why in the first place? I would first like to do a quick survey with you, if you want. How many of you are actually developers, or have been most of the time in your career developers of some kind of web app? Okay, it's me as well. And how many of you have gotten quite a number of bug reports from support that are quite vague, from persons that are not very technical, and you spent a lot of time trying to fix those errors? More than you would like to do. Okay, and how many of you like this process? Yeah, not so many. I thought so. So what we want to do is for you, I mean, we will show you how the architecture of how we do it after a short demo. So maybe you can implement something similar yourself, because you maybe do not need the whole thing. Maybe you need something just a sub-element of what we do. But what you should get away with is with some ideas of how to generate concrete evidence after, for example, a pull request that the change that you did not break a basic functionality, or after an update on a server. Or additionally, what can also happen is there can be some malicious code that you introduce not knowingly. For example, there was a case from, I don't know, the last few months ago with this XC utility. Some of you maybe know about it. And it does happen that some developers will on open source projects for years try to trick you into trusting them and to introduce some kind of backdoor. And the way these guys, at least the guy from Microsoft that discovered it, did it is by noticing that the SSH login took 500 milliseconds longer than usually. And how would you how would you possibly know this if you do not constantly benchmark this stuff and constantly do calls? So this is. And another thing is, of course, it's not about blaming people, because it happens absolutely to everyone. I have introduced a lot of bugs in apps that are made. colleagues introduced a lot of bugs in the estimate, and of course, other people that have no direct relation to me. So what it should help you with is once you have some kind of CI/CD pipeline that automatically triggers, for example, like we allow it to do, a bunch of calls, 10, 15 calls, and maybe even complex scenarios with call transfers, group calls, and yeah, holds, resumes, and so on. Then you should have a basic picture of what your change does, and you don't have to next day get some blame from the team maybe for constantly introducing some kind of stupid bug into the application. And one thing, I mean, some examples of what I've seen with customers of ours, one customer is actually in here, one member of the company is, for example, that we had SRTP one-way audio, but it only appeared if it was IPv6 network and DTLS SRTP, only then, in no other scenario. And the guy that reported it to us was not very technically knowledgeable, the customer who reported it, so it took a long time until we figured it out. And another thing is, of course, also what I noticed is frequently with multiple customers is issues with, at the beginning of calls, you have a silence period, maybe of 1 or 2 seconds, because the packets do not arrive immediately, evenly spaced as you would expect it, and then they arrive after 2 or 3 seconds all at once, and you have like compressed audio that is not recognizable. And this is also something a lot of services, even for the big players, frequently where you can notice something like this. So the other part, of course, is also monitoring. You want to monitor a platform, and we heard a lot about observability, where you will try to use WebRTC, RTC stats, and look into, for example, the round trip time, the jitter, the packet sent, received, and so on. But I think the best way to do it is actually to do a real call, because then you really see, does the call terminate correctly as you would expect it, or does a server somewhere in between cut off the call for some reason? If you measure and record the audio on both ends, you also have a recording at the end that you can analyze. You can put them overlay them over each other, and use some kind of algorithm like vScore, for example, and measure a MOS score, not just a MOS score that you can generate from looking at the bare RTC stats, but one that uses this Google algorithm that they use actually for Google Meet to evaluate the quality of the calls. And what you could also do, and what we do, is you can transcribe the whole thing and then compare what you would expect, what kind of words should appear in the recording. So, and this is very simple. So we use for this, for example, AVS transcribe, and we use Lambda functions for this. It works really fine. So, yeah. So if you want really to have an excellent voice over IP application, it should be tested more than just a developer occasionally doing his own kind of scenarios that he's decided he thinks is important. It should be standardized. It should be recorded from every point of view and logged, and it should be kept so you can compare it over a long time span, the whole thing. And what is easier if you automate the whole thing is to do a lot of testing. So you could have monitoring, for example, that runs every 5 minutes and does a call, or that, for example, does 20, 50 calls after some certain action where you want to check the whole system. And, yeah. Oops, sorry. And yeah, like I said, if you have the metrics, then you can actually say what did happen once you switch, for example, from OVH to, let's say, AVS, or if you moved from the Redis database to something different, what impact does it have on my MOS score? What impact does it have on my post-night delay? Something similar. If you do not do this, you do not know it. So I would say enough of the philosophy, and let me show a demo for you. Okay. This is our Sipfront app. So here we have a bunch of tests, 2 tests actually, with the Janus browser plugin that converts a WebRTC call to a SIP call. And on the other side, so we have, what we do is we start an agent. That's how we call a worker in our architecture that runs, let's say for this test, for this specific test, a Selenium test that goes into a device cloud and then starts a browser of our choosing, types in the login credentials and types in the destination number and so on, and starts a call. And at the same time, and at the same time, we also start an agent that is a bare SIP client. And the bare SIP client is basically a remote controlled SIP client with some additional things that we use on top of that, like Camaleo and RTP engine. And he waits for the incoming call from the WebRTC platform. And let's start it for you to see how it would look like. Okay. Here you see for the first agent that controls the Selenium test, the basic script. So it checks, okay, I'm on a page. He waits for a login button to show up, then types in the credentials. In this case, I use a Linfon account. Then chooses the plain secret register, presses OK and starts the call, and waits 15 seconds and ends the call. Yeah? So, oh, it's already started. So you see here on this side the states of the SIP client. So you see, okay, it is registered, it has received a remote SDP, a local SDP, an incoming call is established, RTP is established, call is closed, and so on. And you see something similar on the browser, the WebRTC version of the states, only a little bit reduced because WebRTC doesn't have all the identical states that we have at SIP. So, or it does have it, but it is proprietary. So it depends on the implementation of the customer. And what we see here is the round trip time, jitter, MOS, okay, packet send, bytes per second, okay, that looks fine. Let me refresh to see the recordings. Okay. Oh, also we have the SIP traces, so you can look at the invites, how does it look like, and compare it, of course, with others. And also how long it took. Here the raw SIP traces, and you have the recordings. And for both sides, you have a decoding version and an encoding version. So this means what the client actually sends and what the client actually receives. You can play that back or down it. I don't think that we would hear it if I start playing. No, we don't. But you can see here on top the transcription result. You can take a look for both of them. Yes, okay. And it's basically a simple message. This is an automated call, blah, 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 okay. And besides that, you also have the MOS score that is calculated. Of course, on our platform, you can configure all kinds of post-processing that you, or let's say, conditions that you want to be met for your test. You can, for example, configure to say, okay, I want the MOS score to never be lower than 4.5. And if it is lower than 4.5, okay, then send me a notification. Or you can say, okay, I want that transcription to be a certain text. And if this call isn't capable of transcribing it correctly, then it implies that the audio quality is not there where you want it to be. And if you go on the platform we use in this test, browser stack, you also have a recording of the whole thing. So let's maximize this. Okay. Yes. I don't want this to. Yeah. Here, besides, you also have network logs. So all the network requests that the WebRTC app is making, you can look at them. For example, let's see this. Okay, you can see the payload, you can see the response, if it's important, and you also have the console logs. So console logs, the Selenium logs, which maybe are not so interesting, and the telemetry, if you want to use it. Okay. Okay. And let's go. I cannot find. Okay. And the thing is, once you have such a platform, you can fairly easily modify such a thing. I hope you forgive me because I have to do it from here. I could, for example, clone this test and say, okay, let's say I'm interested in muting the call or holding the call. That's a muting. The first thing I want the BSI plan to do is assert that the call is established. First, I give it a timeout of 60 seconds. The next action is I wait for 5 seconds. I want a recording. Beginning. Is it there? No. And then I mute. Okay. Besides that, okay, that's it. Save the thing. Test is cloned, and let's start it. And it should see immediately the difference when the test starts in the, let's say, in the RTP packet send. It will take a few seconds. Okay. Okay, it's created. And soon it should start. Yes. And you see that the packets here are going down for the calling. Here on the other side, the received, it goes down for the caller. So it's what we expect, meaning the call is muted from one side of the call destination, of the call leg. And if you wait long enough, I think it takes 30 seconds, so you would also have a transcript result, but I don't want you to have to wait 30 seconds for this to appear, so let's continue. Okay. So let's go over the architecture. Okay. So for the browser test setup, you have the Sipfront app. That's what I've shown you, the user interface. So basically, you have a run button. You can configure the test in any way you want. And you can also look at the history of tests. What it does, it starts an agent, which contains, in this case for the browser, code.js. We use it because it is a nice wrapper that can drive many different platforms. For the browser, it drives Selenium, and it can drive browsers on desktop, so on Windows, on Linux, on macOS, and the browsers that are native on there and available on there. And on top of that, also mobile devices. So you could run, for example, on a Samsung Galaxy S20, a test on a Samsung browser, which is also something that is fairly hard to do automated. Or I rarely have seen something like this available on the market. What it then does is, or what we then do is we inject, oops, sorry, let's go back. Yes, no? Okay, So what we then do is we inject our call analytics SDK into the test itself. I will later explain how exactly we are doing it. But what it does is a Kotlin multi-platform library that has very simple functionality. It goes in there and grabs all the WebRTC, RTCP stats, and you can also send the recordings through it to our platform. It is open source. You can use it yourself and modify it to be used for your platform that you might want to design. And the MQTT, the data is then sent via MQTT to our persister, which then sends it off to various databases. In this example, I show PostgreSQL and TimesTreamDB for metrics and for events, but you can use any kind of different platform you want to use. And at the end of it, there's a finalizer, and he evaluates the conditions of the test. So for example, a condition can be in our test that incoming call must be registered on the BERSIP client, or it can be the DTMF tone must be registered or sent from a certain client. It can also mean I expect a specific SIP address to show up in the contact of the calling, or it can also mean MOS score must be at a certain threshold, and many other different things. And this finalizer evaluates it all and then gives you a result and reasoning why it failed or why it worked, and reports then, of course, back to the UI. The next thing is also for mobile app test. It looks fairly identical, only that it drives Appium with the same type of scripts. So it drives Android and iOS apps. Only here the SDK must be integrated directly into the app. You cannot from the outside go and inject some kind of data into apps or grab them without the app allowing it for you to do it. So, yeah. And for SIP, it looks a little bit more different. Here we have the BERSIP client, that is the remote controlled SIP client. And in front of it, we have Camaillio as a SIP proxy and RTP engine as media handler. And what both of them do, they're kind of like a session border controller. So they will upgrade, if necessary, IPv4 to IPv6, or they will upgrade RTP if you want to DTLS SRTP, for example, or STES RTP, because they're very great at this. If you would want to do this via BERSIP, it would be quite painful to do it. So that's why we're using it this way. And we also use another client for other cases. For example, SIP, if you want to do load test. With SIP, you can do load tests with tens of thousands of concurrent calls. And Camaillio then tells RTP engine, hey, also starts playing RTP media. So you can have tens of thousands of calls in load test with RTP media, with that kind of setup. The agent itself is a Docker image, and it contains, for example, SIP for load tests, or BERSIP for SIP calls, CodeCept for what you've seen for browser tests or for mobile app tests, and Camaillio and RTP engine. And besides that, of course, we also have some different apps that we can use, for example, iPerf for bandwidth measurement. And our system orchestrates all of these Docker images, these agents, together in large numbers if you need it for a test. It depends on the scenario. Maybe you have a test with just 2 callbacks. Maybe you have a test with 20. So it orchestrates them and then aggregates the data into the app and displays it to you in a readable, human-readable way. So let's look at the agent, how it works. Like I said, it's for WebRTC, it starts CodeCept. CodeCept starts Selenium. Selenium gives the device farm, the test script. It can be any kind of device farm. It can be browser stack, it can be Lambda test, it can be source labs, whatever you want to use. And CodeCept also injects certain code. First of all, the call analytics SDK and code for media injection. And the way we are doing it is using monkey patching, basically. So we go into the web app, and with WebDriver, there's a method called execute script. And we just push the whole code into the web app we want to test. And it sets up its listeners. And when, for example, a media stream is requested, then we generate one when we pass it off as ours. And the same way, we also have listeners to listen for starts of media recordings, and then we record it, store it in a file, and send it off to our platform. For mobile app, it's a little bit different. The only difference is, of course, the core analytics SDK is directly integrated, like I said before. Other than that, it is fairly identical. And for a SIP test setup, the BRC plan, like I said, sends simply RTP and UDP. It uses UDP and IPv4, and Chameleon RTP engine will modify it, the headers, the media stream in whatever way you want to need it for your test. And as a bonus, we are also capable we are also using, for example, services like Twilio. So we use SIP accounts from them, and these SIP accounts enable us to simulate PSTN calls. So we start a SIP client that uses Twilio, and then we send a call out to some PSTN number, and it works. So, or you can receive the call via the PSTN number. And once you have this all set up, you basically realize you have no limits. You can do all kinds of test scenarios that you could previously not test, or you would have to have a big team of people that sits all day and types in numbers and enters into Excel sheets the results. And yeah, this is what we are happy to provide to you. One thing that is also very important is, of course, that the service is reliable. So you don't want to flood the customer with false alarms. So if you flood him two or three times with a false alarm, the third time when it is really an issue with his platform, he might not even look at it. So we test our platform in a way, so how should I put it? We do tens of thousands of calls on our own platform every day in order to ensure that it works right. So we use an agent that starts our app and then starts in it another agent that starts a call. And so it's a little bit self-referential, but yeah, that's the kind of thing we do. And what is also very important is, even if the alarms are correct, it should not be too many of them. So you should have some kind of intelligence of what you're doing there and how you present it to the user, so it doesn't you maybe notice if you have a new platform to use, it's nice to use in the first week and you look at everything, but then after some time, okay, it floods you and you just don't look at it anymore. So what are the key takeaways? I think it's very important to test very early and often. So testing, whenever you do a code change, testing, or at least a nightly test. And then testing, of course, monitoring the platform with intervals, at least once an hour. But you can do it like every 5 minutes and just do calls. And once you realize, okay, a call fails, what we usually do, we say, okay, it's configured, of course, for the customer, but what we usually advise to do is to have it retry 3 times. And if it fails 3 times in a row, okay, then, okay, we say probably it has failed, the whole thing. And of course, we want to keep the usage barrier low. So if you were telling somebody to use just SIP to do a load test, it's a very complex and very hard to use tool. So we want to extract to abstract the whole thing away, make it as easy as possible. Yeah. And the last thing, of course, make it reliable. So don't flood the user with useless messages. Don't do too many false alarms. Test your own platform. that you're using to report errors with your service. And that would be it for me. So if you have any more questions about the service, I mean, I can provide you also more details about code-wise of what we are doing here, what we use in some parts, of course, not everything. And if you have any ideas for cooperation, you can always come to me or to Daniel, who is here, and ask questions. Thank you.
Thank you. Thank you, Dominik. So are there any questions for Dominik? Oh, I see one from there.
Hi. I was just wondering if you guys can support testing call transfers, and if so, how is that handled?
Well, if you want to do a call transfer, okay, let's talk about the case where the call is initiated by the WebRTC agent, okay? It starts a call, then via a Selenium script, you press the buttons to add another call, for example. Or let's say you have a second agent started immediately that does via SIP a call that is translated to WebRTC to this client. The Selenium agent picks it up and you have a simple call. And then what you can do in the platform is, for example, you can, in the WebRTC agent, press the button to transfer a call. We have a third agent waiting. It can be a PSTN client, it can be SIP, it can be WebRTC, it doesn't matter what it is. It just waits there for an incoming call, and if it doesn't receive it within a timeout, then it immediately will report an error on the test. And that's how we would do it. And we can also do more complex things. So you could add like 5 callbacks to a conference call, for example, if you wanted to do that kind of thing.
Any other question? Okay, thanks you. Thank you, Dominik.